Right. Hi. It is 3 o'clock exactly, so about time I got started. Hello. Welcome. It's 3 p.m. on a Friday, first day of the summer holidays, and the room is full of people. I'm honored. My name is Christin Gorman, and people have been paying me to write software for about 19 years now. And I work at a consultancy called Kodemaker. And I've mainly been working with Java these last years, but as with so many things in programming, like dealing with time is not something that is only a problem in Java applications, and with so many things to do with good software, it doesn't really matter what language you use, and it's how you reason about problems, and I mean, what makes you a good programmer is pretty universal things that apply everywhere. And I think we really need to work on this as, like when we're hiring, you see so many job ads with, we are looking for developers with, at least 5 years experience in React or, with this programming language or this library. And, imagine we did this with like plumbing or, joiners, like, oh, we're looking for carpenters with a minimum of 5 years experience with Bosch tools, It's like, come on, we don't do this there. That's ridiculous, and I think it's the same kind of thing within programming. I mean, the problems that I've had to deal with in Java are exactly the same kinds of problems that you have to deal with if you're on, working with .NET or any other programming language. So, I'm hopefully, this hour, there are more spaces up front for the people coming in the back if you want. There are, free spaces up here. Yeah. Anyway, I hope that I'll be able to give you some tools and whatever to help reason more effectively about code, and also show you some pitfalls and all the various ways that you can really mess up. And so it's kind of like a horror story, basically, just showing you all sorts of horrible things and some tools of how to deal with them. But yeah, so time. Again, I've been working with programming for ages, but still, I mean, like every project almost, it seems like that we end up with bugs and discussions and like, oh, how do we solve this? And every time it's like, well, how hard can this be? What is wrong with us? Time, it should be so simple. We learned this as kids and we have this kind of intuitive understanding of it. What makes it so hard? And I love this, saw this tweet recently, a friend trying to explain to me some complex inventory system. Okay, let's start with something simple, like a date. Me, whoa, I can't think of anything more complicated than a date. Like, no, not like human courtship. I mean, like January 1, 2019. Like, yeah, I know, and this is just so true, Everyone, I think non-programmers don't realize what a nightmare this is to work with. But why? Time, after all, it should be so simple. It's just seconds passing one after another. And second, I mean, this is a very well-defined unit. It's an SI unit. And I mean, not the most straightforward definition, it's like 9,192,631,770 cycles, blah, 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 cesium atom transition radiation levels. Okay, I don't want to be doing this manually, but, computers should be able to do this pretty well, right? That's why we have computers, because they can deal with this kind of thing, So why is time so hard? And actually, computers are reasonably good at this. If I ask my computer, what time is it? It's going to give me a very precise and accurate answer, But, that's not what I meant. That's not what I meant. No, that is not, the time, the seconds passing, that's not what we mean. And this is kind of the crux of the problem with time, because time is two completely separate things. So on the one hand, you have this kind of accurate linear progression, ticks passing, seconds passing. And then on the other hand, you've got this really unhappy marriage of astronomy and politics and history, and it's just totally crazy, These are completely separate concepts, But if I ask in the second system, what time is it? The answer, it depends, It depends on where the sun is in the sky, where you are on the planet, what the politicians decided should be the time based on, whatever weird things they decided. And this is not actually that straightforward for neither man or machine to deal with, or woman. And they say, or was it Einstein that said that you should always make things as simple as possible, but not simpler. And I think one of the core mistakes that so many programming languages and libraries do when dealing with time is that they've tried to simplify time too much. Like in .NET, you've got the date time and the date time offset. And in so many languages, you have this one concept that's meant to encompass both of these very different interpretations of things that time actually is. So a date time or a date time offset has both this idea of 2 o'clock, and at the same time, it's meant to have this idea of, how many seconds have passed since, some epoch. And, it's trying to merge it together makes it really, makes some things really hard to reason about. So I would recommend for you, like in Java, we had a horrible date library from the outset. Java util date is just, unspeakably awful. But we have now got the new Java time library is based on the Joda time library, and in .NET you have the Noda time library. So the Noda time library in .NET is based upon the Joda time library that is now the basis for the new Java. Anyway, but this is, it forces you to reason more correctly about time. So I would totally recommend, for those of you who haven't started using it, at least look into it. And even if you don't use it, having a good, idea of how this stuff works is going to help you, think more correctly about how time problems can be resolved. So in the Noda time library and in Java as well, then you've got things like instant and local date time, and then the zone date time in the middle. Now, which one of these anyone know which one of these represents the kind of accurate progression of time? So if you're a purist, if you really want to store exactly time passing, none of them actually do that. So if you really care about ticks passing or whatever, you're down to just storing it in some kind of N64 value. But then you have to set it based on GPS input or something. And when you're doing that too, you need to be really careful about naming your variable properly, because again, what are you storing here? Is it nanoseconds? Is it milliseconds? So if you just say timestamp, you're guaranteed that someone's going to misinterpret that. So you need to have the unit, and also which epoch are you dealing with? And in the Windows environment, you've got the .NET. The ticks value and the datetime offset is based on the first ticks since the 1st of January year 1, the Gregorian calendar. And the Windows file time is the 1st of January 1601. And the Unix time is, of course, the 1st of January 1970. The GPS epoch started the 5th of January in 1980. So I mean, you really need to know what epoch you're dealing with, and again, the unit, because these things are very different. If you try to treat a .NET ticks value as a Unix timestamp, you're going to be off by quite a lot of centuries. So these things are very easy to get wrong. But I'll get back to why we can't use the instant later. But what? So many of these things that I'll talk about too. I mean, there's so many cases where there's no necessarily right or wrong answer in what you should use. You just need to, or the libraries can't tell you what you should use. You just need to, decide on something and be aware of the trade-offs. And maybe if all you need is an ordered sequence of events, maybe you don't need to use time at all. If that's what you're using time for, maybe just have a sequence number. And that's probably a really good option in many cases, especially, in the .NET environment. I've copy-pasted some text from Microsoft documentation that says that applications should not rely on the system time to increase monotonically. So you can't even guarantee that time is going to keep, moving forwards. So if you really care about the milliseconds, I mean, use some kind of, a sequence number or something that you can guarantee actually increases. So because the .NET framework relies on the underlying operating system to provide the time information, and based on how that time is synchronized, you can get some surprises there. So just good to be aware of. Just know what you need. What's important to you. But before I get into some more coding examples, we need to talk about the units that we're using. Because this is pet peeve of mine. We learn about time when we're children and we're not mature enough to ask the right questions. And we kind of accept the grown-ups can tell us anything and we believe them, right? You know, and this is when we learn. My kids have just been through like learning about time and 60 seconds in a minute and all this stuff. And they're like, okay, that's how it works. Oh, good, I've understood it. Yay, I'm clever. But that's crazy. The units are totally crazy and we've forgotten about this. So we need to go through all the units. And some of them we're stuck with, of course. You know, like the year. We can't really, you know, we don't really have much of a, you know, the planet rotates at a certain rate and we can't really change that, you know. So we have 365, you know, or 366 days per year. It's like how annoying, like couldn't we get like an integer number of rotations? That is just so unsatisfying, you know, like everything looks fine and then it overshoots by 25. Like, oh, come on. But anyway, that's something we're stuck with, you know, until someone, you know, invents like orbital booster rockets that can keep our planet kind of, you know, at a, you know, integer. That would be awesome, by the way. Can someone work on that? But yeah, we're stuck with this one. You know, we can't do anything about it. The months, though. 12 months? Why 12? You know, a dozen? You know, is that, no? But of course, this is loosely based on the lunar cycle. The lunar cycle is 29.53 days. Again, another like, can it be, what integers? Why? Why this? Ah, you know, people talk about intelligent design. This is sloppy design. We can all agree on that, you know? We don't have to agree about the intelligence part, but sloppy it is. But if you take, you know, the 365.25 divided by that, you get 12-ish, you know? So that's the 12 months. It's of course based on that. And then, of course, we've tried to then spread this out evenly throughout the year. And we have come up with this. I mean, so we start off with the first month has 31 days. The second one, 28 or 29. And then the next one has 31. And then 30, like what kind of drunken maniac made this kind of system? No, but like honestly, think about this. Imagine being in the committee that's gonna decide on this. Yeah, and someone like, I know, well that first 30 and then 30 and then 31 and then 28 and then, you know, like what, who thinks this is a good idea? You know, even the imperial units are nowhere near as messed up as this. You know, even like, you know, like the first foot has 12 inches, the second foot has 11 inches, then the third one has 13 inches. No, of course not. That would be crazy. Why do we accept this? Absolutely, you know, but at least, you know, the only kind of comfort we have here is at least there's some kind of regularity here, you know? You're starting to see a pattern. There's like 31, 30, 31, 30, 31, oh, come on! What is this? This is like a practical joke, you know, come on, like what, you know, this is just cruel. Why? I mean, again, someone decided this. Someone said, yeah, this is what we'll do. You know, it's like, well, yeah, it fits with my knuckles. You know, like, what kind of a, that's not good enough. This is totally crazy, you know, and it doesn't have to be like that. You know, someone made this up. We can't blame the sun or the moon or anything. Oh, well, anyway, hours per day. 24? Like what, 2 dozen? Why? I have no idea. Like no other, you know, anyway. Huh? The week numbers, yeah, I haven't even mentioned those. So hours per day, you have 24 or 23 or 25. And this again is completely the self-inflicted wound of daylight savings time. You know, I know this is like, I'm sure you've all been in the situation where you've had some customer or whatever come with some requirement. Our system needs to do this. And you're thinking, oh, dear God, no, that would be the worst idea ever. That's going to make the system so complicated. And then, you know, like some junior who's eager to please, they go, okay, yay, I can do that. And then you're stuck with some horrible, you know, part of your system that you can never remove again because it's in production. And this is like, daylight savings was a totally horrible idea that has never worked as it intended anyway. And we're stuck with it hundreds of years later. And when people literally die every year, you know, when we move the clock forward, there is a significant increase in heart attacks, you know, because of this, you know, so anyway, thankfully, more and more people are removing it again, but it's taken like 100 years to get rid of this craziness. And again, totally self-inflicted. There was no need to do this. Okay, minutes per hour, 60. You know, like, where did that number come from? And it turns out it comes from the ancient Sumerians 4,000 years ago. They were like one of the first people to set up a written language, and they did it to keep track of their trade deals with whoever they were trading with. And what apparently they had 1 unit of whatever they were trading was worth 60 units of whatever their trading partners were worth. So they set up a 60-based number system. And there you go. So that's why we have 60 minutes in an hour. That's a good reason. That's a good reason in 2019 to have, crazy. Anyway, seconds per minute, also 60 or 61. And this is, of course, everyone knows about leap years, and they come at a regular interval. But leap seconds, there is a committee somewhere that they look at the rotation of the Earth, because it's not constant. It keeps slowing down, but it's not totally regular rate. So at with a 6-month lead time, they decide, okay, we're going to need to insert a leap second to keep our kind of clock in sync with the sun. So then on the 31st of December or the 30th of June, 1 extra second is added to the last minute of the day. So there can be 61 seconds in a minute. And then finally, down to milliseconds, now we have a sensible unit. 1,000, thank goodness. Whew. Or 1,001. Or something completely different. I put 1,001 because that's, again, in Java, that's how they solve leap seconds, because the Java system doesn't have the extra second. Instead, the JVM slows down the processing for the last 1,000 seconds of the day. Each second has 1 millisecond extra, yeah? Which is pretty crazy, but it's better than in .NET, because in .NET, you have no idea. It is undefined. It totally depends on the operating system. And some systems have a similar kind of smearing, they call it, where it's like maybe the latest 20 hours will last a little bit longer. Some don't have any kind of adjustment at all, and you end up just overshooting by 1 second, and then suddenly the NTP sync kicks in, and you're like, hang on a second, now your time's all wrong, and then it gets adjusted afterwards. There is no defined behavior for this when you're on .NET. And now, of course, there is leap second support in Windows, so it will depend on which Windows version you're running on. And again, so this is something, if you care about things like this, milliseconds and stuff, you might want to look into what your system is set up using, because it will have an impact on timing. But basically, okay, so I mean, our units, our whole time system, it's a legacy system from hell. We really should be more aware of our, need for, coming up with more sensible standards. But things have been proposed, and people often laugh it off as a joke. Wasn't there Swatch time or whatever? And there've been, the French revolutionaries. They proposed a new calendar, which was a lot better than the one we have now. There have been attempts, but no one has really taken them that seriously. But anyway, at least there is UTC as a good start. UTC stands for Coordinated Universal Time. No, but you see, it's okay. So it doesn't. Because in French, you see, it's called temps universel coordonné. That's still not UTC, though, is it? And I love this, because this is the best international standard we've come up with. And the way they've come up with the name, and this is true, is they've used the sibling method of deciding or coming to a conclusion where they basically said, well, if I'm not getting what I want, then you're not getting what you want either. So they picked something that didn't work for anyone on purpose, because that would be fair. Yep. That's UTC. So, but anyway, UTC is at least a standard. It's a time zone that, and you're meant to be able to, use wherever you are, and everyone can agree. 2 o'clock. There's no daylight savings. There's nothing, and it's meant to be this international standard, so we can all agree on what time it is. And wouldn't that be wonderful? We had back in the day. In 1800s in the US, I read somewhere, they used to have train tables. If you were in Chicago and wanted to know what when the train left for New York, the timetables were listed based on the time and the head office of the train company that you were running, right? So which was a total mess. You had no idea of knowing what, the time wasn't even where you were. So we have managed to standardize quite a bit. We've come quite a long way. So, I mean, we could start using UTC everywhere. And people, when I say we should use UTC, people are like, no, but come on, that wouldn't work. You have to, go to work at 4 in the morning. Like, yeah. It doesn't matter what number it says on your watch. I mean, you just yeah, okay, if you're in the US, working hours, they start, at some time of the day. It doesn't matter, those numbers don't matter. It would be so much easier if we could all just agree on what time it is. And if you think about it, this is how our calendar works. Right now it's summertime in Norway, it's wintertime in New Zealand, but we still call it June. It's not like we swap the calendar over for people on the other side of the equator. The Winter Olympics are in summertime in Australia, but it's not like, skiing in New Zealand has to, they can still go skiing when it's convenient for them. They don't have to follow, our, it's just like, it's not an issue, We can all get used to UTC. It requires getting used to it, though. Right, and again, with changing things, just think about if you think things are impossible, look at this, the adoption of the metric system. The entire civilized world has already, adopted the metric system, and this has happened, this can happen. We see the same thing here, Celsius, Fahrenheit, we have, people are able to adopt sensible standards. If history has taught us anything, it is that things can change. This is important. This goes for so many things. Whenever someone has some idealistic vision, people are always like, oh, that's going to be impossible to get through. No, history has shown us that we can get things through. We can get this through. Maybe not everywhere. but for most of the world, there's hope. There's hope. Okay. On to some code. Right. Okay. So how do we use these things? I'm gonna try to use NotoTime classes where possible, because I think again they help you reason better about your time problems. Right. So let's say you're working with durations. Let's say you are writing code to schedule a conference like this, for instance. Yeah. So you want to schedule this presentation. 3 o'clock in Oslo. Can I use an instant? Is that a good thing? Because I mean, it's not like I'm gonna be, it's not the 3 o'clock part in a way that's most important. I'm here right now. I'm not gonna be doing this presentation, in an hour's time in Finland, and then again in Moscow, and then no, it's like it is this instant right now that I'm here. And if I'm scheduling if someone's gonna be here again next year, it's gonna be at a specific point in time, right? But of course, I can't do this. You cannot store future things as instants, because we have no way of knowing what instant this is going to be, even if I'm going to do this very talk at 3 p.m. On the 21st of June next year. There is no, I don't know when that is. I cannot tell you what instant that's going to be, because in between now and then, some politician might change the daylight savings rules. Or there might be a leap second, or who knows, things can happen. This is a political thing. So there is no way, you cannot accurately store future times as instants. You can't. So, you'll need the zone and a local time. So either a zone and a local time, or, a zone date time. And when it comes to persisting this, so in practice, what you need to do, you need to persist what time zone you're going to be in. And then you can persist. For instance, you can take kind of the local part. So, here's one. No. I'm sure you can do this in many ways, but this is, one thing you can do anyway. But you need the zone, and then you need to know the 3 p.m. part, 3 p.m. and then the date, and then you can store that as UTC. So if we store 3 p.m. UTC, that's the wrong instant. So I'm storing the wrong instant on purpose. 3 p.m. UTC. That's that's 1 hour off, right? But we'll store that anyway, and then when you get that back out again, you take that time, and then you parse the local date part, and then you can. So I've been trying to do my code examples in F#, which I love, by the way. F# is beautiful. I can't go back to Java now. This is anyway. But here is so you take the local date time part, and then you say in zone, and then you have to have a resolver. I'll get back to the resolvers later. But then if you have the local time and then the zone, then you can kind of, then you can figure out what it is. But that, this has to be a calculation, basically. You can't store it because you don't know what the resulting value is going to be. So figuring out what something is going to be in the future is going to have to be some kind of calculation of a local time and then the zone, okay? Right. How about this then? What if you're not doing conference talks? What if you're having some kind of, like regularly scheduled thing, like a flight? Let's say you have a flight that leaves on Saturday at 10 p.m., arrives Sunday at 6 a.m. Yeah? So start, end, right? But what happens on Sunday, 27th of October, 2019? What happens then? Then we have, of course, daylight savings. In daylight savings time, when you transition, the time progresses normally, all the way up until 2:59, and then it goes back to 2 o'clock again in the morning. Yeah? So 2 a.m. happens twice. So your flight on that particular day, it's gonna take off at 10 p.m., but it's not gonna land at 6 a.m. Unless you instruct the pilot to fly around in circles for an hour, it's gonna land 1 hour early, of course, right? And actually, interestingly, this is one of the things where, the time libraries can't really help you because actually NSB, what used to be the Norwegian rail company, they actually do this. They stop their trains. Yeah? When it's like, it stops at 2 a.m. and it's just like, no, I'm not gonna, and then it starts again, when time is sensible. So, so you need to, there are business rules that come into this as well. But, for an airline, that's not an option, right? And also going the other way, when you're moving your clock forwards, you're gonna have some issues with these kinds of things. So you can't have the start and the end time. A much better way of storing this is you have your start time, and then you have a duration. And you'll have noticed this, of course, in, like if you use the Gmail calendar thing, when you have an event, you put in your start time and then it asks you how many hours or how long is this event. And of course, because that is a much more sensible way of representing, regularly scheduled thing. So if you store it like this, then you will be able to handle daylight savings issues much more effectively. Otherwise, if you have the start and the end, you are very likely that your code is going to be wrong twice a year. So durations, start, and then a duration. But and then a similar problem though. What about this one though? What if you actually depart at 2:30 a.m.? What a horrible departure time, by the way. but yeah, 2:30 a.m. Which one? There are two of them. And what about Sunday? Then it doesn't exist. 2:30 a.m. doesn't exist. What then? So in F#. Here is one method for earliest possible interpretation, and then you take in a local daytime, which is 2:30 a.m., and then the zone. And here this is better than what we have in Java. Actually, these resolvers, I love this. So you have local, and then you pass in the zone, and then you have to specify for both cases. So the first one is for an overlap situation. If there are two of them, if there are two instances of 2:30 in the morning. Yeah. Then you have to. So this first return earlier means which one. You can choose return earlier or return later. So this is which one of the 2:30s you want. And then for the gap situation where there is no 2:30 at all, then here you're saying in that case I say I want to return the end of the interval before. So I'm going to get 1:30 in that case. But you have to basically, when you are resolving from a local to a specific point in time in a zone, you have to specify what to do in case of conflict. And there are many of these there's a lenient resolver, which defaults to the earlier times, I think. Anyway, but you have things like you can mix and match. You can have return earlier and then return start of interval before, or whatever. But so here's the later ones. But these are things that you need to think about. If you have any applications that schedule things, if you don't think about it, it's going to be wrong. And now we're removing daylight savings in the EU. Is it next year? It's coming very soon. So lots of us are gonna, be charged with looking over our code to check that it still works after, daylight saving stuff. So just, look over your code. And these methods really, the NotaTime library really helps you a lot with, having correct code in these cases. So yeah, so again, start time plus duration. and be aware of how to resolve any kind of ambiguous situations with gaps or overlaps. And you know, for goodness sake, again, like try to avoid this kind of thing, you know, like, oh, num hours 24, like, yeah, you wish, you know. Plus minus, you know, don't do your own date arithmetic. You know, if you use the libraries where you can. And I feel kind of bad recommending this because, I mean, look at all this code you have to write just to get tomorrow. But sadly, this is the, you know, it's, you know, what is tomorrow? It's difficult, you know? And I love, you know, the Note-A-Time library forces you to deal with these issues. So it's a, you know, great library. It should, even if you don't use it, being familiar with it really, you know, just helps making you more aware of all the issues that there are. Because otherwise you end up, your code is wrong and you don't even know it. And that's the problem with so much code out there. You know, people are like, oh, I can use date time offset, it's fine. And, you know, and actually, you know, without you knowing it, your code, you know, if you happen to do something at 2 a.m. in the morning, it would break. So, you know, which might not be a problem, but you know, just having correct, you know, I like having correct code. You know, even if it's not likely to run through the night, you know, having correct code is always good. Right. Okay. So storing stuff, persistence. That's another source for horrible surprises. Ugh. So I'm gonna, and there's so many ways of persisting stuff. And again, time at all. I mean, there's so many things I couldn't even begin to cover. But I'm gonna just, you know, bring up some examples from, you know, I never know if I should say SQL Server or SQL Server, but I know that this bottom one is pronounced post-grayskull. So that's, that goes without saying. But, so, you know, I've got some examples from both. I'll start with the latter. So here, so in Postgres, we have the, timestamp is the column that you use to store time. And you can have a timestamp, or you can have timestamp with time zone. And they behave, you know, they have very different functionality. So let's just go through what they actually do. So firstly, the database itself has, you know, an awareness of time. You know, you can say current timestamp will tell you what time it is, what the database feels the time is. Yeah? So if I just insert this, I'm inserting the same value in both columns. And then I get this. And here you can see that with time zone has got, you know, +02 because I'm running this on my machine, which is in Oslo. Yeah, so you can see that otherwise these are identical. You know, you have it's, you know, 1319, 1319, same date, but the with time zone has that added, you know, time zone difference. So this doesn't look too interesting, but anyway, okay. So but we know that the database has an idea of where it's running. But let's take, you know, one particular string, you know, one particular point in time. So this is lunchtime in Sydney, Australia, 31st of July, 2018. So 12:18:45. Let's try to insert that. So if I insert this, you know, and I've got +10, I'm sending in, you know, with 10-hour UTC offset, inserting the same value in both columns, what do I get? Now it gets more interesting because here you can see that the without time zone, it's taking the local time part and it's storing that. And you lose the instant. This is storing the local time. Yeah, so you're storing the concept of lunchtime is what's been stored here. Lunchtime we've stored. But the with time zone, here it's converted this to 4 in the morning, which is what that time would be in Norway. Yeah? And also, you know, when I read about with time zone, I'm like, oh, cool, you can store the time zone. No, it doesn't store the time zone you send. I said +10, but it stored +2. So it doesn't store the time zone you send in. It stores its own time zone. So it converts it to its own time zone, and then it stores that. So, but anyway, the with time zone, basically, it has saved the instant. So it is storing the instant. The timestamp column has stored the local date. Yeah? So those are, you know, again, that's storing the totally different concepts. Anyway, so what if we use code to insert? Again, just look, this is so beautiful. You know, you should have seen the Java example I had before. It was horrible. This is, oh, I like this. So I'm inserting this with code. And then I'm sending in, again, same strings. I'm parsing this and I'm passing it into my insert event function. What happens then? So here, now with time zone is exactly as before. That I'm getting the, you know, it's converting it to the local, or to the, you know, what the time is in my time zone. But the without time zone is also getting that, you know, local, you know, whatever it was, you know, in my time zone, because of course the code is converting this datetime offset, is treating that as, as an instant and where the application is run. So, okay, so we've inserted this. We got the same local time value in both. What happens if we get it back out again? Let's try to get this back out again, okay? So here, I'm going select now. I'm selecting it, and here I'm just, for the hell of it, trying to convert this to a node time value. So remember, this is what we inserted. We inserted, the lunchtime in Australia, and in the database, we've got 4 in the morning in Norway. Okay, so what happens now if I run this? What is this? So I'm printing out the results at the end. What am I going to get? This. So here, with time zone now, has got UTC -4? What the hell? So now it's saying 4 in the morning -4? Whereas the without time zone has got the day before 10 p.m. -4. What's going on here? And this is because between my first insert code and my second select code, I changed the time zone on my computer. So now this code was running with the time zone set to New York. So not only does the database have a time zone that it will use, but so does, so will your coding environment. The .NET environment is going to take the time zone information from the underlying operating system, and it's going to use that. So if you are not explicit about which time zone you want to use, it's going to use whatever defaults it finds. And that's, so, I mean, the lesson here is you need to be really careful about being explicit about what time zone you are parsing the return values from your database from. Because as you can see here, this is completely the wrong instant. And all of a sudden, these things are switched over. So now it's the with time zone value is now storing the local date part, whereas it's the without time zone that suddenly has the correct instant. And this has without me changing the code at all. This is just about suddenly the operating system had a different time zone. And if you have microservices architecture or whatever, you have different machines running in different places. If one process is inserting values and another one is reading them out, you really need to check that everyone's time zone settings are totally in sync, or you need your code to be really explicit about what time zone you are going to be interpreting these values as. Because this really, this is gonna, you can easily get the wrong values out or in if you're not aware of this. Yeah. And so SQL Server, I had so much fun with that. Has the column is not called there. We don't have timestamp. We have a datetime column. The datetime column has an accuracy rounded to increments of 0, 0.03, and 0.007 seconds? What on earth is that? Look at this. This again from the Microsoft documentation. So if you insert a value, the 1st of January in 1998, at 23:59:59, 9999, so this is clearly within the 1st of January, your database is going to round that up to the following day. So it's going to store completely different. And it's like and then the next one, these 4 will end up being Anyway, this and clearly someone at Microsoft has realized that this was kind of embarrassing. So now they've kind of improved it a bit. So now they have a new, which is called datetime 2. Datetime 2. Has sensible, accuracy. So, for goodness sake, do not use datetime. Anyway, datetime 2. That will store the value you actually insert. Whew. And if you want to kind of, be more explicit about your time zones, you can also do this in SQL. So here, for instance, if I want to insert my my timestamp value here, even though this string includes the zone at the end, that's not enough. You still have to tell it that, okay, so I want this is a datetime 2. I need to, make sure it's a datetime 2 value. And then I say that this, interpret this as Australian Eastern Standard Time. And then I want to store it at UTC. Yeah. And you need both of those things. You need two time zone things. The first thing you say, this is what I'm presenting it to you as, and this is what I want you to store it as. And it's the same going out again. So also things to be aware of when you are inserting and getting things out again. And what struck me, of course, with this kind of stuff immediately was like, what this isn't this? What kind of a time zone name is this? And in the time zone, the official time zone database, of course, is the has the Australia. This time zone is called Australia/Sydney. And in Europe you have Europe/Oslo, America/New York, and you have this sensible structure. But like, what is this? And of course, in the NotaTime library, you explicitly choose. You can choose between the TZ, the time zone database, the official standard one, or you have this, weird Microsoft stuff. And if you don't use NotaTime, apparently you actually, like, for instance, I'm running on a Mac. I won't have this. Is not going to be part of my Mac installation because this is a weird Windows thing, right? This is I don't even have that definition of time. So if you specify that time string and try to run it on Linux or on a Mac, you're going to unknown time zone. So, and I love, like, here is a list, and this is probably too small for you guys to see, but these are the names of the Windows one or the Microsoft ones, and I just love, like, what the hell is this? Central Standard Time? He's like, how arrogant is that? Central time, the US is the center of the universe, of course, like central where? And I love these too. Central Europe Standard Time versus Central European Standard Time. What the difference is, I don't even know, but these are, again, it would be, I would encourage anyone at Microsoft to please, use the standard names. They are much better. But anyway, this is also something, again, because, the various underlying, since you can now run .NET on Macs or on, Linux, you might not even have these things. So having a mapping between these and the official time zone standards is also good to be, aware of that might be needed. Yeah, but anyway, please make sure that you have some automated tests against a real database. There's so many people who say, oh, you should never test. You never have like unit tests or automated tests against the database. You should mock out the persistence layer. Do not mock out the persistence layer. Please make sure, there are so many surprises you can get, with the various persistence layers. Make sure that you've got automated tests that run against not only a database, but the same kind of database that you were using in production. There are all sorts of weird and wonderful little tiny differences, the ways of handling null, and again, like, strange issues with like truncation of milliseconds or whatever. I mean, you need to have, run some tests against an actual instance of your database just to do some sanity testing. Like, is the value I'm inserting, is that the same one I'm getting back out again? These things, you can sadly not take them for granted. So please make sure you have some. And also, where possible, try to, persist timestamps as UTC. It gets so confusing. If you have, as I've, shown already, there are so many weird and wonderful versions of times that can end up in a database. So being standardized on just having the knowledge that what I'm seeing here is the UTC time makes things so much easier, and you don't have to. And then you can deal with casting and converting it, and when you're reading it out or yeah. But anyway, just it makes it a lot easier to standardize on that in the databases. But of course, then. It's hard to give kind of universal advice that always works, because there's so many trade-offs no matter what you do. Because if everything is in UTC, of course, and then you get you can easily get a request to make this report, for instance. Yeah, let's say you've got a store. You've got store A, B, and C, and you want a list of their, what they've sold, the values that they've sold for every day of the week, for instance. And then what if store A is in Sydney, and B is in New York, and C is in Oslo? What is Monday? How do you do that? How do you even select that? Monday was going to be completely a different time in New York based on or from Sydney. So, but you can do this in SQL, but it's not necessarily pretty. So I'm just going to just show you some. SQL stuff that you can do for this is SQL Server stuff. So let's see, we have a store with a time zone, and then you have a list of transactions. So this is obviously very simplified. So if you want to make that report, the simple, kind of the first naive approach would be to just, select the store name and then the sum of the amount, and then the date, the weekday part, right? That's going to give you the Monday or whatever. And then you join it and blah, and group by date part. But of course, again, that's not going to give you, that's going to give you the Monday based on UTC, which is probably not what you want, because then you're going to get, especially, in Australia, you're going to get half a Monday, half a Sunday, which is not going to give you what you want. But you can select things out. The database knows about time zones, so you can pretty much always have, like here, for instance, you can make this, temporary construction as you're querying, so you can select stuff, select the time zone blah, and then at time zone UTC, and then again at the store's time zone, and then you can call, as adjusted time, and then you can select from that again, and then group as before. I don't know, but this, again, performance-wise, it might be, you might have to store it in the local time zone after all. So, I mean, this is a trade-off. But I say you can do these things in code, or you can do them in SQL. Yeah, so I can't really tell you what's right for you. But there are, many options anyway to deal with that. Okay, date ranges. Again, when you are selecting stuff, make sure, again, to standardize on, you want to have inclusive from, exclusive to, just be consistent about that. And when you're testing this is where you discover the date time rounding issue, by the way. You insert something at, 59,99999 milliseconds, and you assert that it's part of your data set, and then of course it isn't, because the date time thing has shoved it out of your range, and you spend hours anyway. But this is, just standardize on this, so you never have to worry. Very, yeah, easy to have bugs if you're not consistent about this. Okay, so testing. Quickly, this very often you'll end up having to, you want to deal with now, right? So here's I've got an insert event here. I insert some text, and here I want to insert, my text, and then now, yeah, because this is when I inserted it. But how do you test that afterwards? As I said, I've said you should test that what you insert that you get back again. So, imagine testing this, I send in, I want to assert that the event that I got back has timestamp equals what, Now is obviously kind of a, where do you get that from in your test? And the NotaTime library has this iClock, which it encourages you to use. So to get the current instant, instead of saying datetime.now, you can get the clock, can give you its current instant. And then in your production code, you kind of use a system clock. And then in your tests, you can use a fake clock. So your production code just deals with the iClock interface. And then you can, insert a fake one in your tests, and then you can have your fake clock return whatever times you want. I've really enjoyed playing with F# when making my code examples here, but I don't have any experience with using this. But I still feel pretty confident in saying, just don't use that. Don't this is there. But a much better way of doing this is to just don't deal. Mocking just makes your code more complicated, and it is much easier to solve the testing problem by doing something completely different and much simpler, and will work regardless of timing library. If you need to use now, just separate it out like this. Your insert event, just have it take in a parameter, yeah, and then in your test you call this insert event with a specific time, and then you have a collection of times in your test. You have a nice parameterized test with lots of instants that can be problematic, like right before a daylight savings transition or something. So you collect up a whole set of difficult time points, and then you pour them into your test, and then you call this method directly with that. No mocking required, and it's just much easier, much cleaner, better in every way. And then, of course, from production, you just call this, which is just a wrapper around that. So in production, you say insert, insert now, and then there you insert the now point. But then you kind of, then you don't have to call this in your tests. So your tests just focus on this important part here. So yeah, I mentioned again parameterized test. Try to make sure list up, especially if you're doing like date calculation stuff. Again, like scheduling things, regular, stuff that you need to, add 3 months to something. Just collect up a whole set of difficult time, points in time right after daylight transition, right before, and then have tests that that assert that all of these, that you get the expected results in durations or what you get in or out or whatever, and time zones and stuff. Just collect a whole bunch of time zones, difficult points in time, and then have a test suite that just verifies all of that. Right, I will end with this. I was in favor of space exploration until I realized what that would mean for, date time libraries. And, like this is hard enough, with just the Earth and the Sun. And if we start, Mars and the Moon, and oh God, anyway. But I want to turn this around. I want to turn this around. Instead of dreading this, we should take this. This is our call to arms. We want to go to Mars. We want to explore space. So we have to tidy up our timing system. We have to at least fix our units and standardize more. So here's my to-do list. First, we need to get rid of daylight savings. Yeah, and the politicians are already doing a good job, but we have an important role to play here too. Because so many people, whenever you mention that, oh, we're going to get rid of daylight savings, people are like, oh no, but all our computer systems are going to crash. Yeah, and everyone's like, oh no, that's going to be so much work. Now we need to make sure, we need to go through our code, make sure that it is correct and that it works, whatever people do in changing zones, so that when they finally change the daylight savings and get rid of it, we can go, yay, and we've been part of the solution. So this, step 1. 2, we need to introduce UTC. And I think, again, as developers, we need to try to sneak in UTC all over, and I think we need to find a better name for it too. UTC is ridiculous on so many levels. But, like we could call it, international time or global time or travel time or something like that. We can give it a good name, especially for like traveling applications and stuff where time zones are a hassle anyway. Just try to sneak in the UTC time, get people used to using it. It would be so great. Just imagine like conference calls and stuff, yeah? When you have like people working remotely, being able to say, yeah, the meeting's at 2, and everyone knows when that is. Wouldn't that be wonderful? We really need to, we can do our bit. Try to, sneak in UTC where you can. And then again, can we please replace the month with a, sensible, not this 31, 30, 30, 28, what the hell? We need a better system for months. Yeah, we can do it. Yes, and lots of stuff. And then, of course, then we need to think about, after that, we can go to TAI, which is the atomic time. But anyway, that's another talk altogether. Right, I'm out of time. So I will say thank you for listening, and good luck.